What from worksheet 4.5 could I help you with? Yeah. Number one? Cool. I'm going to sit back here. Can I sit back here amongst you cool people? Not because anyone's doing anything wrong. It's just I'm showing off because it records all the way back here. Number one, you said, huh? All right. It's always good when you start a worksheet and the very first problem you're like, uh-oh. All right, so is that the right problem? Cool. All right, so very first thing you want to do is let's not deal with the denominator. Let's move this denominator up. And we're going to move it up, so this is going to look like this. X squared plus 2 to the negative third power. And it's technically over 1, but I don't know. I'm not, excuse me. I'm not going to put that. Is that okay, first of all? So that means I'm going to do f of x equals x squared plus 2 to the third power. So when I want to do the derivative of this, my first thing I want to do is I'm going to take care of this, bring this down front, and then you're going to subtract 1 from that. You're going to put your original equation, which is this, and then I'm going to take the derivative of the inside, and that's the only thing that has a derivative. So honestly, in this class, if you left it like that, you're perfect. If it was a multiple choice question, they would probably have this as an answer. Oh wait, that was a -3, so that should have been a -4. I'm sorry. And that should be a -4. And then what they might do on a multiple choice test is they might do this. But honestly, I don't think I have it. I'm not going to have this one as a Schoology. So answers that are totally fine on here is if you got this answer here, if you got this answer here, or if you got this answer here, there's not one that's going to be more correct than the other. Okay? So that's kind of a weird one because we have something that we can do a derivative, and then it's like a derivative of a derivative. So it just keeps going. Okay? What else could I show you, help you with, go over? Yeah. 5? Cool. All right, number 5. Is it okay if I change my P's and Q's to Y and X's? Is that going to be okay with you? I just think my P's and Q's start looking bad. So first thing I'm going to do is I'm just going to change the signs. Is that okay? All right. So if we wanted to, we could use the quotient rule on this. And the quotient rule is derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay? So let's see if we can follow that rule. Derivative of the top is just 2x. And then I'm going to multiply it by the bottom. Okay, so we took care of this portion of it. I'm going to subtract the derivative of the bottom. Well, the derivative of 2x is just 2 times the top. Okay, so now we've taken care of that. And it's all going to be over the bottom quantity squared. That's the derivative. So that quotient rule is a valuable rule. It's helpful, especially when you're not having to deal with moving things up and down and side and side and negative exponents and all that other kind of stuff. Okay. What else can I help you with? Yeah.
Can you do number 9?
Number 9? Yeah. Number 9, find all the coordinates x comma y which the slope is tangent is 0. Ooh. Okay. So let's think about what this means. Find all the xy points. So what it means is where the tangent 0 is on your original graph, like let's say your graph looks like this. There are two spots on this graph that the tangent line 0. It means it forms a horizontal line. Okay? So, and I don't know if this is what our graph looks like necessarily. We're going to use Desmos here in a second. But we're trying to figure out what these xy values would be. Okay? So, thoughts? Any thoughts? I haven't really taught this. Let's see if we can decipher it. Let's see if we can use a little logic here. So we have this. That's our equation. I'm going to take the derivative. This is really the only thing I have to take the derivative of, taking into account that. So I have f prime at x equals 3x squared minus 4 to the second, because I had to subtract 1 from that. And then the derivative of the inside times 2x. I'm going to clean it up a little tiny bit. So that's going to give me 6x x squared minus 4 to the second. Okay. So let's just pause there for a sec. Do we feel okay with how I did the derivative? Okay, so we want to find the exact values, the exact xy points. And it doesn't have to be 2 points. It could be 1 point. It could be 3 points. It could be 4 points. We'll figure that in a second. But as far as the derivative goes, does that make sense what I just did? Okay. All right. I guess I wasn't supposed to check 4 or 5 off today, so I apologize. So I'm supposed to check it off tomorrow. It was supposed to, I'm off a day. I'm all goofed up. Let's see. Yeah. Okay, so I'll take care of that. So here's the trick on this one. We want to figure out where the tangent is equal to 0. Okay? So I'm going to change this to 0. Is that okay? Now this kind of reverts back to algebra 1. I'm going to take this, divide each side by 6, so x equals 0. Okay, so I'm going to hold on to this for a second. And then I'm going to take x squared minus 4 quantity squared equals 0. If I take the square root of both sides, I'm not going to worry about the plus minus at that point. I'm going to get that. This will then become, if I add 4 to both sides, move that up so you can see it. You see it better now? Yeah. Okay, sorry about that. So now I'm going to take the square root of both of these. Do not forget the plus minus. So that means x equals 2 and x equals negative 2. Okay. So there's actually 3 places on this graph that the tangent would be 0. Okay? So what I'm going to do with each of my points is I'm going to plug them back into the original. So I'm going to have 0 comma something, 2 comma something, and negative 2 comma something. So we have to figure out the somethings. So what I'm going to do is I'm going to plug 0 back in. Oops, not onto the derivative. Wrong one. I plug 0 back in here. Okay, and I'll plug in 2 and also negative 2. So my original equation on that problem was f of x equals x squared minus 4 to the third plus 12. All right, so let's plug 0 in first. So I'm basically going to do f at 0 equals 0 squared minus 4 to the third plus 12. So that's going to give me negative 4 to the third plus 12. This would be, if you don't know your perfect cubes and calculator, negative 4 times negative 4 times negative 4 is negative 64 plus 12. So negative 64 added to 12 is going to be negative 52. So at 0, comma 52, okay, that is a point that would be a turning point, whether it's going up to a maximum or coming down to a minimum. But right at the exact maximum, right at the exact minimum, it's going to work. Then I'm going to take 2 and plug it into the original equation. 2 squared minus 4 to the third plus 12. So that's going to give me 4 minus 4 to the third plus 12, which gives me 0 to the third. 0 to the third is obviously 0, so that gives me an answer of 12 there. And then you might see this, but just in case you don't, I'm going to take this, I'm going to plug it in as well, f at negative 2. So I'm going to get negative 2 squared minus 4 to the third plus 12, which is going to give me 4 minus 4 to the third plus 12. So that gives me 0 plus 12. So these are the 3 locations where our graph, that if I found the tangent line exactly at that point, it's going to make a horizontal line. Horizontal means it's parallel to the x-axis. But that's definitely that's a trickier problem. It's definitely trickier. So, and of course, I leave you a half inch of space to try and write the answer to it. Big jerk I am. Anything else off that page we can take a look at? 11? Sure. All right. Word problems, our favorites. These are the ones that stir up left blank when I was a kid. Suppose that the demand for Q units of a product is priced at $P per unit described by that equation. Okay. What is the rate of change when Q equals 49? Interpret the answer using A in a full sentence. Okay, so we have P equals 200,000 over Q plus 1 to the second. Okay, so I'm going to turn this into this. Q plus 1 to the negative 2. Now I'm going to do the derivative. So this negative 2 comes down way up front, so I get negative 400,000 Q plus 1 raised to the negative 3, because I'd have to subtract 1 from that. And then the derivative of the inside is just 1, okay, because I took the derivative of that, got that. So P prime is equal to negative 400,000 Q plus 1 to the negative 3. We could clean it up a little bit, having P prime equals negative 400,000 Q plus 1 raised to the third power. Woo, baby. All right, what is the rate of change at Q equals 49? Okay, so if I'm gonna take that 49 and I'm gonna plug it in right here. I'm gonna get negative 400,000 over 49 plus 1, so I add 50 to the third. Now I'm gonna go to our graphing calculator because Stirrup's not going to do that in his head right now. Come on. There you go. Clear. All right, let's go here. So negative 400,000 over 50 to the third. $400,000 divided by 50 raised to the third power. Ooh, negative 3.2. Comes out to a nice answer. Y'all know about this key. If you hit math, fraction, enter, gives you negative 16/5. That's simply the greatest key on this calculator, I think. So negative 3.2 or negative 16/5, either one. Let's see which one will make more sense. So we have negative 3.2 or negative 16/5. All right, interpret A. Using it. Suppose that the demand for a product is priced at that described by that. Okay, what is the rate of change of the price when it's 49? So it's negative 3.2. So negative 16/5. So I'm going to keep it as the fraction. So we lose $16 for every 5 units. Something like that. And I'm not going to make you do these word problems. I just had this on a homework. I'm not going to put this on a quiz for you. It's nothing better than word problems. You know what's the best, though? When your teacher says, hey, read the problem aloud in front of the class and picks on somebody. You want to know what stirrups thing is? Hannah, you probably remember it. 5th grade, Mrs. Klatt. Chris, we're reading about space travel. Will you read the story while the rest of us read silently? Oh, okay. Well, it was a story about a kid going to Cape Canaveral. Okay, I'm in 5th grade. I can barely, sound out a one-syllable word, no less Canaveral. But if you're a 5th grade kid named Chris Stirrup, Canaveral looks mighty close to the word carnival. And the story basically went like this. Peter and his family were going to go watch their first rocket ship launch. They were excited to go to Cape Carnival. Teacher, Chris, it's Canaveral. Oh, okay. And as Peter and his family approached the stands to watch the launch at Cape Carnival, Chris, it's Canaveral. Oh, okay. The rocket engines fired up. Loud booming sound. All of Cape Carnival. Chris, it's Canaveral. Why can't you say it right? Because I'm a moron. Couldn't stand having to read aloud in class. Made me feel bad. All right, so let's do this, friends. That's the life story for you for the day. Let's be sure. Let's see. So 4.5 would have been we were working on yesterday. That means working on today. So be sure worksheet 4.5 is done. I'm happy to walk around and help you. And again, friends, if you have stuff that you owe me, there's one student that has the very first Schoology quiz. It's still open, but it hasn't been done yet. And there's about 10 of you that have the second Schoology that you haven't done yet, so make sure you have that done. I'm happy to grade them as they get done, but if they don't get done, it's a goose egg sitting in the grade. And then if you ever see any homeworks that either I accidentally didn't put in or you didn't show me for whatever reason, that's homeworks. That's an S. Be sure those are done too. Let's not get to 3 days before graduation and you're showing me, 2/3 of the book of problems you've done. Okay? Because that's when your counselor's email, hey, look, Billy needs your class to graduate. I email back, Billy has a 3% because Billy hasn't done anything. Well, they need to need your class to graduate. Maybe that communication for Billy, and if your name's Billy, I'm sorry. So, we got a Valentine card coming. I'm excited. How are you? Good, nice to see you. Let's see. Harrison, you here? Harrison? Dalton, you here? Pass that up to Dalton. Tilly, you're up here. Hannah, hand that up to Tilly. Harrison, you're here? We had them all here. Harrison he was figuring out how he can make a dash for the door. It's an escort. I'm running. All right, so sound good? Everyone good?